Thanks everyone for sticking around for our first panel. So Dionysius already did a pretty good job at introducing a lot of the challenges. So we're not going to be able to cover all of them, obviously, but I hope we'll cover a good sum. So in this panel, we'll actually do a bit of a more technical dive. Dionysius was more of a high-level kind of vision talk. So yeah, this panel is about the open problems in blockchains on both the engineering and the science perspective. So let me start by quickly introducing our panelists here. So we have Suresh Agarwal, who is the CEO of Pod Network. Pod is a new layer one which removes consensus as we know it in order to achieve, among other things, optimal latency. So next we have Fotini Baldimtsi, who is an associate professor at George Mason University. She's also a research advisor at Miston Labs, which is the company behind Sui and recently Walrus as well. And last but not least, we have Odysseas Lamzidis, who is the founder and CEO of Phylax Systems. Phylax enables developers to define some security rules. So if a smart contract if there's a transaction that violates any of these smart contract rules, then the network will reject that transaction, right? Maybe preventing some hacks from happening in real time. Quite exciting. So obviously there's a lot of open problems to cover. So let's jump right in. I'd like to start with the kind of elephant in the room that Dionysius motivated already, which is usability. So as Dionysius put it, blockchains are unusable. It's a nightmare, right? So they're still painfully hard to use, developed for both developers and everyday end users, right? In my opinion, it's usability that's really holding us back from mainstream adoption beyond any other technical bottleneck. So to kick off this kind of topic, I have a question for Odysseas. So regarding the developer side of things, how do we onboard the next million or so Web 2 developers onto Web 3 with security in mind?
Well, actually, I think there's two issues with crypto actually that adoption is. One is the UX, and the second is security, right? So we have a system that is hard to use for most people, and then we have a system where you may lose all your money at some random time, right? So actually, I think DevX has improved quite a bit over the last few years, at least in Ethereum, where I've been mostly at. The first thing whenever I talk with Web 2 people or like engineers that have like more classic background, it's a very different mindset, right? Like when you code a smart contract, first of all your code is public, right? You ship it, and then people have an endless amount of time to go through every single line of code and find a bug. So security through obscurity is not you can't do it anymore. And then you have a bug bounty, whether you know it or not, which is equals with all the money you have locked in your account, right?
Sitting honeypot, basically.
Exactly, right? And this is why bridges have been like so often hacked, right? They're the biggest hacks have been bridges because they had so much money in them, right? So it's worth spending some amount of time trying to find a vulnerability. I think another very important aspect, at least in Ethereum, is Solidity and the EVM and their Lindy, right? Where in a lot of ways it's like JavaScript was awful at the start, and then after billions of dollars invested in it, actually now it's pretty good with TypeScript, V8, etc. So there's a lot of tooling in Ethereum now, and actually the developer experience is much nicer. We know the system, we know the EVM, we know the foot guns. There's a lot of content for engineers to understand the system they're building. So actually, I think that's improving a lot, right? You can go from zero to hero in like 6 months, right? And finally, I think the biggest difference in mindset is the second and third order effects, right? You're building money Legos. You're building something that someone else will hook onto to do something else, and then you probably depend on some other system. So all the engineers that build smart contracts, they also have to beat to be a bit of security engineers, and they have to also be a bit of mechanism designers, right? Most hacks are not, anymore at least, not because of like some vulnerability in the smart contract. This is becoming rare, but it's because that you had some environment in mind when you coded it, but then you use some other primitive, some lending pool, some Oracle, which somehow there was some edge case which it put your smart contract out of the environment that you thought you were enforcing, right? Because you can't enforce the other smart contract. So it really needs, and that's the hard part, to really think about all the second and third order effects and how not only how your code will react, but how your mechanism will react in a very weird market. Most of the applications are financial, right? So it's like in weird market conditions, right? Maybe you're using some Oracle, which is some value. You want to understand what's the value of a token. But if that token, for example, has very low liquidity, someone can manipulate that value, and a single transaction can inflate it by 400%, right? And then it will make your smart contract react to that in a way you didn't expect it to be, and then they will be able to get money out of your smart contract.
Right. Yeah, so I guess staying on this DevX topic here, what's your take, Stress? Like, is it going to be something JS-like? Is it going to be something programming language that's more Rust-like, so Solidity? Or is it going to be Move? What's going to win here?
Yeah, Odysseus has already covered some important points, but I feel like writing contracts is a new paradigm. Even though we are writing code, you have to really think differently, because it's no more the liveness aspect of, if the system works, it's probably fine. It's the safety aspect that brings all the value to the system. And safety is very interesting because you have to protect it against all possible combinations of attacks. While liveness is usually, if it works, you have some kind of already feeling that it's probably correct. And irrespective of whichever language we choose, it's going to be a huge learning curve for developers to get to know all of these foot guns, as Odysseus was mentioning, which can start from low-level language and language semantics of overflows, underflows, and little nuances of how your encoding scheme is, because a lot of things can go wrong there, to going higher level to protocols and even how it reacts with the market. And with Solidity, at least, we have got a better understanding. Like, we have a huge set of auditors now who know what are the common foot guns, and there's a lot of learning material out there, and people have got familiar with it. And if we come up with a new language, there will be a big learning curve. And even though we can all agree that Solidity is ugly in some ways because it doesn't have most of the basic features, right, that you would expect from a modern programming environment, somehow it sticks, and somehow people have got used to it. So my intuition is, at least in the short run, it's going to be still dominated by Solidity unless we build up this appetite and learn a new language slowly, right? It might be the PHP or JavaScript of the Web3 in some ways. Yeah.
Yeah, that makes sense. I guess switching gears a little bit and talking about the end user experience, right? That's super important as well, not just DevX, but real users, onboarding them. So as Dio mentioned, one of the big pain points right now is that you have to deal with the hexadecimal addresses and the accounts and all of that private key management. So ideally, we don't want to deal with any of that, right? So is there something we can do? Can we do better?
Yeah, so Dionysis already gave a great introduction to the problem of usability on the user side, and he showed you a screenshot of a MetaMask wallet and how complicated this can look to a user. So just to make sure that everyone is on the same page, right now in the crypto space, there are two ways for users to handle their accounts. They can either use a third party, some sort of exchange, and trust their keys with them. And the purists, as Dionysis was calling them, they might want to handle their own cryptographic keys. And in that case, they can use wallets like MetaMask and have these applications help them handle their keys. But again, it's a lot of responsibility that you place to users that they are not going to lose these cryptographic secret keys. And MetaMask, for example, has this mechanism that allows you to create a seed phrase that consists of 12 words that you have to remember them. Most of the users are going to write it in a piece of paper, and you need to use that in order to reconstruct your secret key in case you lose it. So all this is completely unfamiliar to the average user, but luckily, cryptography comes to the rescue here. And there are cryptographic techniques that we can use in order to make user authentication on-chain as easy as having a Google account. ZK Login is a protocol designed by Sui that is an example of that actually allows users that already have an account with an existing provider like Google to reuse that account in order to authenticate on-chain and do transactions. And the cryptographic mechanism used for that is what we call zero-knowledge proofs. And it allows users to do that in a very secure way and with privacy added as an extra perk.
Yeah, I mean, that makes sense. I'm curious if ZK Login, something equivalent to that at least, exists also on Ethereum. Have you guys seen anything? I don't believe so.
I think it should be replicatable, right? It's just you just need to deploy a contract that verifies now.
There is a proof of concept from Risk Zero, I believe.
Does it require any hard forks on Ethereum, or does it just work natively?
No, it's just an application space. And also now with Ethereum, there's a big discussion about adding a new curve as a precompile in Ethereum, which will enable using what's it called, like your password manager to manage
BLS 1231. I think that was included actually yesterday in Petra.
It was included.
Yeah. So
cool.
It's live. So
yeah,
we have everything we need. Let's build it. I mean, yeah, one of the crazy.
We don't have
things-
users though.
That's fair. Yeah, and I'm sure we can spend this whole session just talking about how to fix this usability problem. But I think another kind of important topic here to cover is privacy. So suppose we've solved the usability for now. So how do we ensure privacy in these systems which are like inherently transparent, right? That's kind of the overarching problem here. And going back to you, Fotini, we've seen multiple attempts at achieving privacy in blockchains. We saw a surge in privacy coins in like 2016 to 2018. There was Monero, there was Zcash, all that. Then came mixers like Tornado Cash, which ended up being sanctioned by the US government, US Treasury. So none of these have really taken off. And my question to you is like, is there any hope in achieving privacy on chain? Is there some technical limitation here perhaps?
That's a great question. So I think there are two challenges when we're talking about privacy. The one being technical and the other not. So the non-technical aspect has to do with regulation and has to do with policy and has to do with exactly what level of privacy we want in the systems, what exactly do we want to hide. And that's a very tough question. And the answer is very different depending on which authorities you're talking to. The second aspect is the technological one. And although Dionysis in his talk before, he highlighted how many advances there have been in the past few years in scalability and so on, the landscape in privacy preserving techniques is not as is not as great yet. Again, a lot of advances have happened there, but still the tools, the mechanism, the cryptographic tools that we need for privacy are not as fast, as scalable, as efficient as we would like to. So you mentioned Zcash as one of the most prominent privacy-preserving cryptocurrencies, and it is the one that has the higher level of privacy, if you like. And it's based, again, on this magic cryptographic tool that is called zero-knowledge proofs. But inefficiency in Zcash is actually a big problem. And there was an interesting analysis done on Zcash at this point, like quite a few years ago. So Zcash has the option of either using coins in a privacy-preserving way or using coins in a traditional way. And in fact, most of the transactions done in Zcash, more than 90%, they are done in a non-private way. Why? Because doing them so in a fully sealed, in a fully private way is extremely expensive. It takes a lot of time. And especially in the early years of Zcash, there were no good wallets or user interfaces that a user could use in order to make these privacy-preserving transactions. So it's a complicated question, a complicated challenge, both on the technology side and on the policy regulation side.
Yeah, for sure. Staying on the technology side a little bit, so how does privacy, do you think, Odisea, affect the developer experience here? So adding things like ZK and such.
Well, it's, I mean, there is a reason why, none of the private systems, privacy programmable blockchains have taken off, right? I mean, one thing is regulation, and people were actually fearful for their, lives in pursuing these projects, and that was a very fair thing, especially for Americans. Although now, Tornado Gas was removed from the sanction list, and we seem to be seeing a renaissance. But yeah, it changes the mental model of something already weird to something even weirder, where the developer has to think about, public inputs, or like in my program, what things are publicly, what inputs are known to everyone, and what inputs should only be known to the user, and then, when you have a blockchain and you have the state machine, right, which runs by everyone. For example, if you have an AMM, you can't have private input the number of tokens, right? Because the blockchain needs to know the number of tokens in order to compute the state function of all the trades. So it changes the developer experience quite a bit. Aztec and I think Maiden are probably trying to, Noir seems to have been finding the right balance in making something that's actually usable by developers and hiding a lot of the ZK weird circuit stuff. I think a very interesting new kind of newish, wave of privacy is using trusted execution environment, TEs, where basically you trust the CPU, the cloud provider, and also you trust the CPU creator like Intel. And basically you encrypt your data with a private key that is inside their CPU, and then the data will be decrypted inside the CPU. While this has like worse security guarantees, obviously, than ZK, it has a much simpler model to think about, because when the state transition happens, then all the data is available. And also it's almost near native speed, right? So there is no performance hit on privacy. So I think TEs are a very interesting newish paradigm where now the DevX is actually becoming easier. So we might see some TE-based privacy solutions. And
Flashbots is doing some of that, right?
Yeah, Flashbots is one of the organizations in crypto that have been pushing really the boundaries of TEs in terms of scalability and privacy. TEs and ZK, you can think of them as the same product, right? They solve the same problems, but in the different way in the trade-off spectrum between security and both solutions effectively they provide either scalability or privacy, right? When I say scalability, I mean verifiable computation.
Right. Yeah. So clearly, there's a trade-off here, right, between DevX and privacy of some sort.
Yeah.
I'm curious: is there stressed any trade-off between privacy and performance? Do you think?
Yeah, definitely. I mean, there is no free lunch, and I think Putini already kind of covered this, right? That performance for these privacy-preserving cryptographic primitives are usually much, much worse than just doing it natively. And if you guys are familiar, I mean, we mentioned ZK a couple of times, but if you've ever tried to generate a proof, ZK proofs take a lot of power to generate. I mean, you need big machines, and the bad thing here is because now you also want privacy, you cannot delegate it. Delegation is no more an easy thing. There might be cryptographic primitives that allow you to delegate, but if you just use the classical primitives, you would have to generate the proofs locally on your own system to preserve the privacy. So it pushes most of the ZK applications, at least from the verifiability side, delegate the computation to an external server, a big machine that does it for you, but here you would have to do other tricks to bypass it. But also there might be some ways to look into like flexible models where you kind of layer the privacy aspects, right? I mean, Odysseus already mentioned about TEs, but you can think of the base primitive not having privacy, right? And it's just being secure and live in the normal traditional blockchain setting, and then kind of building privacy on top and using primitives which are maybe slightly slower or uses TEs, and you can have different assumptions while still relying on the base layer. And yeah, that could be one way. And I think privacy is a very critical aspect if you want to go to mainstream adoption, where you don't want to allow for people to see all the balances and everything for everybody.
If I may add
Sure.
a point to this, Nicola, a complementary challenge to this, to the problem of privacy, is accountability, right? So the thing is that with all this space of like open payments, right? Accountability is not really a problem, right? Because as opposed to traditional financial systems, these payments are completely public, completely transparent. So the moment that you add privacy to the system and you're sealing, you're hiding everything, then the question of how can I hold someone accountable, how can I make someone pay taxes on what they own, it becomes a big problem, right? So ideally, and this kind of goes back to the efficiency problems, right? You don't only want to build systems that are privacy preserving, which adds extra efficiency costs, but you want to build systems that are privacy preserving and accountable at the same time. So it's like double the cost in a sense, right?
You should be able to audit the script without disclosing kind of obfuscated.
And this adds additional cryptographic tools to do, right? So efficiency becomes like even worse.
Yeah, makes sense. Yeah, so I'm sure we can also talk about privacy for the rest of the session, right? But let's try to cover one more topic, because I feel like, assuming we've solved usability and privacy now, does any of it really matter if we can't handle like the global demand? So if we're trying to build here the worldwide ledger that Dionysus envisions, right? We need to look at scalability. Like the overarching question is can blockchains like realistically support the scale that other protocols in Web 2 like Visa, MasterCard, and maybe global social networks support without sacrificing the ethos of decentralization and such? So starting with use rest, one big problem I have in general with popular blockchains, let's take Ethereum, if there's some, let's say, NFT auction that's happening, right? And it's super popular, everybody's trying to buy the next ape or punk. Now, if I'm trying to pay for my coffee downstairs, right? There's a huge gas spike, and I have to pay like this huge transaction fee just because there happens to be some other protocol that has a lot of congestion, right? In the traditional web, we don't see this, right? If both, let's say, Netflix and Spotify are using AWS, right? They're both hosted on AWS. If Netflix has a premiere and now everybody's there and it's congested, that congestion will not propagate to Spotify listeners, right? So how do we fix this in Web 3?
Yeah, a very interesting question. So if you look one step deeper behind why this happens, right? Why when there is a big NFT launch, everything else slows down? It's because the way blockchains are designed today is every transaction blocks every other transaction. And this is the kind of inherent requirement of consensus and how we interact with blockchains today. And if you come from like traditional databases, right? Think if you would acquire the global lock to your system for every interaction that you do with the database. And this is the reason why it's slow. It's like, you have one single machine and everybody who wants to talk to that machine has to do like this time sharing to get his transaction in. And as we've seen with computers, right, where things got more distributed and asynchronous, and we had, multiple processes and then even asynchronous systems with several servers, blockchains are also moving towards it, right? Blockchains in the start there, so far we have synchronous systems with full consensus, but there has been a line of work recently where you can make things parallel and you don't need to have every transaction blocking every other transaction. And these systems can scale much better, and there you would not have the same problem where if you had two popular applications that have no correlation with one another, they would not spike each other's gas prices. And I think Sui has been doing some of the work, and there's been a lot of interesting research work around that.
Yeah, definitely. Staying on a bit the Ethereum landscape here, this is for Odysseas, who I know has been quite active in the debates around the Ethereum ecosystem, especially on crypto Twitter, right? So it looks like over the past couple of years, Ethereum has focused on this, on the rollups as the go-to, let's say, scalability solution, right? But recently, it looks like there's starting to be a shift to actually scaling the L1 itself. So how do you see this playing out in the long run here?
One of the most interesting interactions I had was, I always wondered how Solana thinks about the end game, right? And I tweeted about it, and then Anatoly, who's the founder of Solana, was like, what's the end game, right? How can Solana, without horizontal scaling and AWS and whatever? And he's like, well, right now we have approximately 10-20% saturation on our network suites for every node on a 1 gigabyte connection. When we hit 100, we'll think about that, right? And that struck me as a very pragmatic approach, which is we'll focus on making the L1 right now as fast as possible. We will eat all Ethereum's market, and when Ethereum is dead and we're 90% saturation, then we'll think about scalability, right? And we'll figure it out, right? And this is a very different research-driven versus product-driven mindset, where on Ethereum we try to first of all, sharding, let's try sharding. We spent 3 years, was like, actually, we can't figure it out. Let's privatize the research on sharding, so we'll have rollups. We can't figure that out. And now we had rollups, and then actually they suck, right? With there's fragmentation of liquidity, there's fragmentation of state. All the value of Ethereum is on Ethereum state, the content, right? And that's on Ethereum, and it's very hard to access it. And now rollups are basically Base. What happens if Ethereum, for example, and actually Base is parasitic to Ethereum, like they have like 50 million per year on gas revenue, and they pay like 3 cents and an ice cream to Ethereum, they buy a cake to the Ethereum Foundation once per year, and we haven't figured out the economics, right? Rollups are actually parasitic to the economics of Ethereum. And what happens if Ethereum, spikes the Ethereum DA, right? We say you have to pay your share, and what happens when the DA becomes a cost center for Base? Will Base stay Ethereum aligned, or will the Base board of directors will say, screw Ethereum, let's go to Celestia because it's costing us 10 million per year, right? So I think because we haven't figured all these questions, and frankly, we don't have the need for so much scalability. Now I think we're trying to be more pragmatic again, and we're trying, okay, let's focus on making the L1 a bit faster. Let's accept that it's okay if Ethereum can't run on a Raspberry Pi. Let's accept that as a common sense. It's okay if you pay 1K. I mean, if you're paying 70K to stake your Ethereum, probably you can pay 1K for hardware. So I think it's more of Ethereum after winning and becoming fat and complacent on things, then suddenly realizing, oh, we're actually losing on a lot of metrics from Solana, where it has users, has great DevX. DevX, no, it sucks, but it has great UX. People are having fun. There's good content, good apps. There's no people, on Ethereum, and now we're realizing that, okay, maybe we need to scale the Ethereum L1. Maybe the value of Ethereum is on its state, the content. And in the meantime, we can allow the L2s to figure out how we have composability, how we don't have this fragmentation, how we make it easy to go from one rollup to another, although there is no incentive for Base to have composability, right? So that's a question whether the rollups will actually try to have composability because there is no incentive to have. So I think it's coming back, we are waking up very violently from the market, telling us that we have to get our shit together, and if we don't mature the L1 and evolve it, then it will become irrelevant and will die out, and we'll have a very good tech that nobody uses.
So you think this reality check has hit in for Ethereum?
Yeah, I think we have new voices inside the Ethereum ecosystem, and there is a common understanding now. There's like this ivory tower on Ethereum research where, I mean, also you saw it from Ethereum engineers, like the lead engineer from Geth, who's the main Ethereum client. He's been tweeting since 22 that we have to, that the current situation where research will define goals and then will just throw shit over the fence to engineering to implement is not working since 22, right? And now we're seeing this result where, people are saying to researchers, okay, take a step back, go play on your own thing. Let's just actually ship a product.
Yeah, let's see how that plays out. We're running a little bit out of time. One other thing that I wanted to touch upon here is, we mentioned zero knowledge in the context of privacy, but it looks like ZK, zero knowledge proofs, has also been pretty relevant in the scalability side of things as well, right? And we're seeing a lot of companies out there that slap the term ZK on everything they're doing, right? When they are really only using like the snark aspect, right? They care about the succinctness side. So what's your take, Fotini, on this?
Just to make sure that, again, everyone's on the same page here. So zero knowledge proofs are a cryptographic protocol or a cryptographic technique that was proposed back in the 80s, and the inventor of it actually won a Turing Award. Okay, so it's a very important technological breakthrough. So zero knowledge proofs, in a very, very simple way, allow you to prove that you know a witness, a solution to a public problem, to a public statement, in a way that you don't reveal anything, not even a bit of information about this secret solution that you have, about this secret witness that you have. So they were invented with privacy as being the main tool. However, as zero knowledge proofs evolved throughout the time, and the existence of blockchain and cryptocurrencies was actually the driving force. So if you look into the history of research in zero knowledge proofs, you're going to see that most of it happened in the last decade, exactly because of their applications to blockchain. You're going to see that the way that zero knowledge proofs evolved allowed you to create proofs about statements that were very, very short, okay? And be very, very succinct. So the goal in these proofs was to have a verification procedure and a proof that is very short, and also the verification procedure be very, very efficient. So zero knowledge proofs were used many times without caring about having privacy on the statement that you're proving, but just having it as a byproduct. So zero knowledge proofs, for example, are a main building block in rollups that Odysseus was talking about, but without really caring about privacy there, only caring about succinctness. So what's my take there? I mean, the fact that they're not using privacy, sure, but I think it's very, very interesting how this cryptographic building block evolved. And it was one, for me as a cryptographer and as an academic, it was very interesting how blockchain was used as a driving force to push all these results in cryptography that we knew for decades.
Yeah, very interesting. All right, I think there's a lot more open problems to talk about. Unfortunately, we've run out of time. So I guess we got to cover some usability issues, some privacy, and some scalability. Obviously, there's interoperability, among many others. So yeah, let's thank the speakers. And I don't believe we have time for any questions, maybe one or two. All right, let's take one or two questions from the audience.
So you've been mentioned that crypto, first of all, amazing and very well structured presentation. So you've been mentioning that cryptography can assist in improving user interface. Now with like the rise of AI, do you think AI can be implemented in order to resolve those the user experience, let's say, make it easier for the common person like myself? I'm not an engineer, so do you think AI can assist on that?
Who wants to take this?
Well, I think there's one aspect about using AI to write smart contracts, and I'm not the right person to
I
answer
would
that.
not recommend that at all.
But
Let's
there are
not
good
do
reasons.
that.
Yeah.
Let's please not do that.
I've seen a poster which said, vibe code your next smart contract. Our friends from North Korea.
And certainly AI is not the right tool to invent cryptographic protocols, for sure.
Yeah,
I
but
think where you could use is build better wallets, and you could have AI interfaces to explain you things or use it in a way that you can kind of interact with it. But it's hard amalgamation, at least on the usability side. Maybe others as well.
Actually, I think now we're getting to a place where actually LLMs are they don't hallucinate anymore so often. So it seems like it's a good. I would say like having an LLM input to control your wallet and do things is something that actually a lot of experimentation is happening from, if I remember correctly, from base engineering of like agents. And it seems to be a good, it's not a solution, but it's probably part of the solution, right? Like probably you want for the user to input what they want to do, and then the LLM will convert it into some action. And then hopefully we'll also be able to tell you in simple words what it will do, so you can verify the action before you actually do it. I think it's probably part of the solution, yes. Yeah, for sure.
And I have a second question, but this is mostly like investment-wise. You've been like doubling down a lot on Ethereum, and not Solana or Avalanche or other similar, let's say, environments. Why like Ethereum out of all of those? Like you've seen something in Ethereum, I'm guessing. What is like the engineering side? Like why do you like Ethereum so much? Like you've been doubling down a lot on them.
Ethereum has been running for 10 years. It has 10 upgrades and not 1 hour downtime.
And like at least it's sufficiently decentralized. It's not controlled by you and your uncle and your investors, and it's really validators running and being used.
So it's more trustworthy, let's say.
It's very
like in
lindy.
comparison to Solana, let's say.
It's withstood the test of time,
Yeah.
that's for sure.
Okay.
But
Also,
yeah.
Solana, I would say, is sufficiently decentralized. Not the same aspect, but like not saying Solana is not decentralized. I think it's cope,
Okay.
realistically. Like it's depending on the use
You can
case,
turn
right?
it off.
Yeah. All right, I guess we can leave this as an open question here.
I want to make
Yes.
one final note,
Very
really
quickly.
quick, 10
Yes.
seconds, on one of the challenges that I think we have to focus on solving in the next few years, and we didn't mention it yet, and this is post-quantum security. So most of the current blockchain systems do not support that. The directions are that in the next decade, we have to transition to post-quantum systems. That's something that we should all be thinking about.
Great ending, I believe. So thanks again.